Good morning, students. Today we will discuss about the topic that is potential difference and flow of charges. Actually, this type of topic you will not find in your textbook. But today I am going to explain that how this flow of charge is possible due to potential difference. Okay. So let us construct two electric fields. One is the positive field, another is the negative field. These are the two electric fields. Now you have already read about the potential difference. What is that one? That is the amount of work done to move one unit positive charge from one point to another point inside the field, and provided during that motion a opposite force will be existing. That means what? If I try to bring one unit positive charge, from this negative field to this positive field and settle that charge at a certain point inside this field, then we will be able to know what is the potential difference of between that point from where the charge has been brought and to the point where the charge has been kept finally. Okay, so that is a different thing. Now let us see how this potential difference. Definitely there is a difference in potential between these two electric field areas. So we will see how this potential difference will help in the flow of charges automatically. Okay. As I have read in the definition that we are doing some work on the charge and the charge was moving from one point to another point. So we were responsible for pushing that charge. But we will see that how the charges will move without our effort. Okay. Now let us connect these two fields with a piece of copper wire. Let us connect these two fields with a piece of copper wire. Now we know that the copper wire has atoms, neutral atoms. So as soon as these atoms come in the contact with this field, then what will happen? This negative side, this negative field will try to pull the nucleus, whereas this positive field will try to pull the free electrons. So in that process what happens? These atoms, they ionize. That means the valence electron comes out of the atoms. The valence electrons comes out of the atoms. So the valence electrons, now you see they have come out of their atoms. And what is left in the atom? This is not an atom now, this is a positive ion. Okay. So what will happen? This positive ions will start moving towards the negative field and these free electrons will start moving towards the positive field. Okay. So you see, during this motion we are not doing anything. We are not giving any force to the positive ion or the negative charge electron. Automatically the charges are moving from left to right and right to left. Okay. So this type of flow of charge contributes to electric current. Okay. So how long this flow of charge will continue? The flow of charge will continue as long as we are maintaining these two potential differences. Means here we are not applying any energy to move the charges. In fact, we are applying energy to maintain this potential difference. We have to apply some energy to maintain this potential difference between the positive field and negative field. So as long as this potential difference is maintained between these two ends, the flow of charge, positive charges towards the negative field and the electrons towards the positive field will continue. So this is the relation between potential difference and the flow of charge. See how potential difference is responsible for the flow of charges in a conductor. Okay. I hope you have understood this concept. Thank you.